Hello, everyone, and welcome to another mini lesson about basic concepts of chemistry. Today, I will talk about the concept of mole. Mole is just a unit to measure the amount of substance in the chemical world. The definition is 1 mole, it's equal to Avogadro's number of particles or chemical entities. So I will write here Avogadro's number in honor of Amadeo Avogadro, who was an Italian chemist that contributed a lot to the understanding of chemistry. So Avogadro's number is 6.022 times 10 to the 23. So it's a huge number. You have to move 23 times the decimal point to the right to get the number. So it's a million of the million of the million of the million. And the number must be that large because atoms are so small that you need to gather a lot of atoms so you can measure a significant amount or a significant mass in a scale. And the mole, we can imagine it as a bag. Down here, you see different bags. These represent this imaginary bag that it's a mole. And the bag can hold exactly this number of chemical entities. What do I mean by chemical entities? They can be atoms, entities, they can be atoms, or they can be ions, or they can be molecules. Okay? So we can talk about a mole of iron atoms, a mole of carbon atoms, or we can talk about a mole of sodium plus ions, or a mole of water molecules, a mole of CO2 molecules. Okay, so that's why we use the term chemical entities. So the funny part here is that, for example, let's say I want to fill this mole bag. So I want to fill 1 mole bag of hydrogen atoms. Okay, so if I put exactly this number of particles of atoms inside this box, and if I take that box and weight it on a scale, the mass that will appear on the screen will be exactly this number in grams. And the funny part is that this number is exactly the number that you can find on a periodic table that's defined as the atomic mass or atomic weight, okay? So this is very useful because we can check on the periodic table the atomic mass of any element. And if I express that value in the unit of grams, I know and I'm sure that I'm talking about the mass of 1 mole of that substance. That means the mass that corresponds to gathering this huge number of atoms and weighting them on a scale. Okay? So because this mass corresponds to the mass of 1 mole, we can express this as the molar mass, that is grams per mole. So this is an important concept. The molar mass of any substance is the mass in grams that weighs 1 mole of that substance. And remember, 1 mole is exactly equal to the Avogadro's number of chemical entities. So for example, if all of these bags are 1 mole bags, but they are made of different substances, let's say hydrogen, carbon, oxygen, all of these 3 bags will contain exactly the same number of chemical entities, in this case, the same number of atoms. So in the hydrogen bag, because it's 1 mole, it will have 6.022 times 10 to the 23 atoms of hydrogen. The next bag will have 1 mole of carbon. That means it will have exactly 6.022 times 10 to the 23, etc. But the difference is that each one of these bags will have a different mass, because think about it, each one of the atoms that's inside the bag, it's different. So hydrogen atoms are super light, super small, but carbon atoms are 12 times larger than a hydrogen atom because they have more protons and neutrons, okay? And the oxygen is even larger than the carbon and the hydrogen. So you have the same number of particles in each one of the bags, but the mass of each one of those bags is different. The mass, the molar mass of carbon will be around 12 grams per mole. Okay, that number, you can find it in the periodic table. And in the case of oxygen, will be 16 grams per mole. Okay, this is telling you that although you have the same number of particles in each one of the bags, because each individual atom is heavier than the other, going from left to right, the total mass of that bag, or the molar mass, or the mass of 1 mole, will be different. Okay, so we can use actually this value of the molar mass as a conversion factor. Okay, if you know the molar mass of an atom, of a molecule, or a compound, you can use that data to convert, for example, grams of any substance into the moles of any substance. And you can go backwards. If you have, let's say, 10 moles of hydrogen, you can use the molar mass to convert it to grams of that substance. So the concept of molar mass is very useful for the calculations that we need to do to convert, for example, to calculate, for example, in a chemical reaction, how many grams of some reactant are needed to produce certain amount or certain grams of a product. Okay, so the mole, it's super important in chemistry to understand and to make calculations about chemical reactions. Thank you very much, and see you in the next video.